Okay. Hello Evie, how are you? Yeah, I'm doing pretty well, thank you. So, we'll get started in about 2 minutes just to let everyone filter in. And we're going to do ratios today. Oh nice, is that paper 3 then? And I assume it's year 10 mocks? Yes, nice. Okay, how's that? How have they gone so far? Oh, year 11, nice. Cool, perfect. Hopefully they've gone well. +70. Yeah, pretty good. I mean, that'd be a very good grade for you. And it'll give you a good idea of where you're standing before the exams. I mean, yeah. That'd be really amazing. But again, even if you don't quite get there, you've got a few months in order to actually achieve that. So, you know, it's a really good head start. It's really good either way. Ah. Okay, so you want to make sure you're improving. That's good. It's a good goal to have. But no, hopefully it goes well. Hopefully you can let me know next week. Okay, so let's get started. So yeah, welcome back everyone to one of the GCSE lessons. Today we're going to be covering ratios. So it's going to start off relatively simple. So this is like the basics of sharing in a ratio. But there are some questions towards the end which are going to be basically the hardest ones you can get, just like we did with probability, okay? So it will get gradually more difficult, okay? And again, if it's too easy, then you guys in the chat can just let me know to skip ahead. But we'll start off with the easy stuff and end up with the much harder stuff, ideally. So, basics of ratios. So, it essentially tells you how many parts people get. So, Will and Ollie share £80 in the ratio of 3 to 2. Work out how much each of them get. There are two main ways to do this. One way is to kind of visualize it. So, if I do 3 plus 2, that's 5 pieces or parts in total, right? So if I want to visualize this, I can have a big bar, right? With 1, 2, 3, 4, and 5 pieces, okay? And Ollie is going to get 3 of them, so Ollie, 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 and Will is going to get... That's the wrong way around. I can't read. Okay. Will is going to get 3 pieces. Will, and then you have Ollie and Ollie, okay? So Ollie gets 2 pieces, Will gets 3. So if it's in 5 parts, we can do the £80 divided by 5, which is £16. So each part is worth £16. So Will gets 3 times 16, which is £48. And Ollie will get 2 times 16, which is £32. And a good way to check if your answer is correct is if you add them together, we still get £80. So that shows that we're correct. If we get a number that's different to 80, we should be a bit worried. Okay? The other way to do that is to just use fractions. So to convert a ratio into a fraction, all you need to do is you look at the number you're interested in. So if I look at will, I'm looking at the number 3, and I divide it by both numbers added together, 3 plus 2, which is 5, and then multiply it by 80. Okay? Which you're still doing the exact same thing, and you will get 48. And so with Ollie, you do the same thing. The number we're interested in is the 2. 5 is the total times by 80. Okay? £32. So either way, it's going to be exactly the same. A-level physics will come soon. I'm just trying to find some time that I can do the lesson for it. But yeah, that's kind of the basics of ratios. To share it, you can either visualize it, so make a bit of a block, say how many parts you've got, or you can use the fraction method here. Okay, whichever one is preferable to you. Okay, but in future, I think I'm going to stick with the fraction method, if that's okay. But if you're not sure about that, then let me know. So again, slightly more difficult. You have a 3-way ratio. So Molly to Paige to Demi is 3 to 2 to 1. But it's no more difficult, okay? It's just longer, right? So work out the number of sweets each of them gets. So they have 42 sweets. So if I do the ratio method, if we work out Molly, the number we're interested in this ratio is the number 3. And then if I add all of them together, 3 plus 2 plus 1, that gives me 6. Okay? So 3 over 6 is going to be our fraction, and then multiplied by 42. 3 over 6 is the same as just 1/2 though, so a half times 42 will be 21 sweets. Okay, so Molly gets 21. Next one. So I will try and get it done before the 21st of November, but if there's a specific topic, let me know, and then I can see if I can get a video out for that specific topic, okay? Then if we go to Paige, we have the number we're interested in is 2, so 2 over 6 times 42. So this is the same as doing 1/3 times 42. And you get that, and then lastly we'll have Demi as well. So 1 over 6 times 2. Yeah, and that should be okay. And again, you can also use a calculator to work these out. So these ratio questions can come up on calculator or non-calculator. Either way, it's fine. So if we start just working these out. Again, forgive me, I'm being slightly lazy today. 14. Which means this should be 7 because it's half of that. Okay, no worries. I can try and get a video out for that shortly, like a mechanics overall video, okay? Perfect. Again, I'll try my best, but time is a bit constricted at the moment, okay? So hopefully that's fairly easy with the ratios. So is everyone okay with that? It's okay? All good, all good. Perfect. Okay, again, we're going to get on to more difficult ones. And yeah, I will do that for the A-level maths. I'll do it at the end of the lesson, okay? Okay, so again, we're just going through all the different types, so it's going to gradually get more difficult. So all good so far, it's perfect. So we have ABC as a straight line. So A, B, C. The length of BC is 3 times the length of AB. The length AC is 80 meters. Work out the length BC. Okay, so because this is a ratios video, you can probably guess it's going to be a ratio. So, but how can I tell, right? Like in an exam, you won't know that it's a ratio. Well, it's telling me that BC is 3 times the length of AB. So the way I write that is BC to AB is equal to 3 to 1. Okay? Because that's how you say a ratio in real life, right? So for example, if I said that I have 2 times as many apples as pears, the ratio of apples to pears is 2 to 1. Okay? So we have our ratio, that's good. Now it's telling me to work out the length of BC if the total length is 80 meters, right? So this whole length here, not exactly accurate, but yeah, 80 meters. This is 3 parts, that's 1 part. So what we're going to do is look at the fraction, or the number we care about. So, which is the 3, divided by 3 plus 1, which is 4, times 80. So a quarter of 80 is 20, times that by 3 is 60 meters. Again, you can use a calculator. Sometimes this might be a non-calculator though. So hopefully you should know how to times by fractions now, so you can do 80 divided by 4 and then do the times by the top. And that would be fine. And that's it. And that's a 3-mark question, right? That's not too bad. It's quite quick as well. So just let me know if that's okay. If that's not what you meant, could you rewrite it? If you mean to like break down exactly what papers and how many marks you get, I'll do that at the end. All good. Perfect. Okay. This, again, it's a new style. So we're basically doing one of each style of question, but it's getting slightly more tricky. So we have Carly and James share, so C to J is in the ratio of 5 to 3, right? Okay, cool. Now it's telling me that Carly gets £70 more than James. So I think this might be good to visualize using the little squares that I did before. So in total there's going to be 8 squares, right? 8 parts. 2, 3, 4, 5, 6, 7, 8. Okay. Now, James gets the first 3, and Carly gets the other 5. Right? But it's telling me that Carly gets £70 more than James. Okay? Now, so Carly gets 2 parts more than James. Yep, 70 extra. 2 parts, and those 2 parts are worth £70. Right? So Carly gets £70 more than James, and she also gets 2 parts more than James. So 2 parts is £70. So 1 part is £35. Is that okay? Good. Okay. Perfect. So if we want to work out sorry, excuse me. If we want to work out how much money James gets, well, if each part is £35 and James gets 3 parts, he gets 3 times 35. Ooh. So 3 times 30 is 90, so that'd be £105. 3 times 5? It's £105. So again, they can ask you, you know, it might catch some people off balance, but hopefully that's all okay. Cool. In a very similar vein, right, we have Jerry and Mick share some money in the ratio 2 to 3. And this is very similar to the previous question, okay? So Jerry to Mick is 2 to 3. And it tells me that Mick gets £900. Okay? There are 2 ways to do this, by the way. I'll show you the way I prefer, and then I'll show you another way. Now, Mick gets 3 parts, so we know that 3 parts equals £900. So 1 part is 900 divided by 3. 9 divided by 3 is 3, and then we just add the zeros back on, so £300. So then Jerry gets 2 parts, so it's 2 times 300, which of course is £600. Is that okay, or do you want me to show you a different way to do it? There is another way to do it, which is as quick, yeah? The other way to do it, just so you're aware, is what people like to do is write the ratio again, but they say, okay, Mick gets 900. So how do I get from 3 to 900? So you do 900 divided by 3, you times by 300, which means you have to do it to the other side as well. Okay. Perfect. Sorry. And you get 600 again, so it's the same thing. But either way, perfectly fine. What I will say is that this style of question can't be done in this second method. So since I'm a bit lazy, I like to know just one method. I like to use the parts method because it always works. But if you want to use both, it's totally fine. It doesn't really change anything, okay? I think that's all okay. Good. Wow. So again, this is like a second go at not the last question, but the question before that. So Ali and Steve share some sweets in the ratio of 2 to 7. Okay. Steve gets 30 more sweets than Ali. So Steve gets... So what we know here is that 5 parts equals 30. So I've jumped ahead a bit just to give you a bit of a test. Is that okay? Can you see the jump? Because Steve has 5 more parts than Ali, and he has 30 more sweets. So 5 parts is 30 sweets. Perfect. I hope that makes sense. So 1 part is 30 divided by 5, which is 6 sweets. So how many sweets does Steve get? Well, Steve will get 7 multiplied by 6, which is, of course, 42 sweets. So again, you're probably thinking ratios might be a bit easy. I do have some harder stuff coming up. But if you're finding it really boring... Oh, vectors. So Lila. I thought vectors would be the next thing I did until we recommended ratios. Vectors will be the next thing unless you guys have something more urgent to do. Okay, so if you can all agree on something else, vectors is definitely what I have planned because I think it's the next hardest thing. And yeah, I think vectors. Vectors and bearings, yeah. Okay, so vectors would be the next thing then. Let me just write a note to myself. Just in case I forget, but I shouldn't. But vectors was definitely on the agenda. But yeah, I can do it in the next thing. Okay, so... yeah. Is this really, really easy and you want to jump ahead to some harder stuff, or should we keep going at this pace? Is this okay? If you're bored, let me know. Too easy? Okay, cool. So... this is probably easy. I think that's fine. That's fine. Okay. That'd be a bit easy. Actually, wait. What about this? It's our first 4 marker. Does that... Sounds easy as well? Okay. Though it might be slightly harder. Let's have a look-see. So I'll go through this quickly. Yeah, so Lila, towards the end there are some. I'm not exaggerating. They're actually pretty tricky ratio questions towards the end. We will definitely get through them, so don't worry. But should be some of the tricky stuff. I'll go through this one relatively quickly, but this is another situation that ratios can come into play. So in a bag there are red, blue and white counters. Counters taken at random. Here's a probability. We've done this before, but it tells me here that the number of blue counters to the number of white counters is 2 to 3, okay? So we have to fill in the table. So blue and white is going to equal 1 minus 0.35, right? Which is 0.65. Because all three of these should add up to 1. Okay? So these two together add up to 0.65. Now the probability itself, because the number of blue counters is going to be equal to the probability, right? Is in the ratio of 2 to 3. So your thing for blue will be 2 over 5 times 0.65. Okay? And let's just use a calculator, be a bit cheeky with it. So 0.4 times 0.65. 13 over 50. Okay, it's a good thing I didn't do that in my head. Actually, should we do it as the... It's 0.26 as a decimal. Okay. And then white is going to be everything left over, or if you want to be really meticulous, you could do 3 over 5 times 0.65. Okay. So again, I just wanted to make sure that we got through all the different style of questions anyway, even if they are a bit easy. And that would be 0.39. So 0.26. Okay. Is that still easy? Probably. The ratio of 5 to 4. I think this one's fine. Wait, let me read this question again. 3,000 euros. Yeah, this is fine. This would be fine. Have a read of that and see if that's a bit more tricky. There's more words, so might be ever so slightly more tricky. I think this might be okay. Easy, okay. I'm fairly certain you guys wanted ratios. And now you're saying they're easy. Okay, 4-mark question. Let's go through this one just to make sure we've done a 4-mark question. Okay. So, shop sells small chocolate bars and large chocolate bars. There are small chocolate bars which are sold in packs of 4, and the large ones are sold in packs of 9. On a day, the ratio of small to large is 5 to 2, and a total of 95 chocolate bars were sold. Yeah, sure, Lila, we can. So work out the number of small chocolate bars sold. So, again, not too bad. The ratio of small to large, so S to L, is 5 to 2. So what we're going to do here is work out the fraction of them that were small. So small equals 5 over 7 multiplied by 95. So again, we could work this out, or we can be lazy. I prefer to be lazy just for this case. Oh, wait, I made a mistake. So this is the number of chocolate bars, not the number of packs. So on one day is the ratio of the packs. Okay, but we're saying a total of 95 were sold. So that is going to be fine. So we get a pretty hideous number. But what we can do is, if we write the whole thing out, right, then all we need to do is times that by the number of chocolate bars. Okay, and that will be the answer for that one. Can you do the above one as well? Yeah, sure. So, what I want to do here is, because there's a lot of information, I need to be extremely careful, okay? So this is a 4-mark question, so again, Harry and Gary have a total of 300 stickers. The ratio of the stickers Harry has to Gary is 7:3, okay? So we have, and then afterwards, Harry gives Gary some stickers. The ratio has changed to 8:7. Work out how many stickers Harry gives to Gary. Okay, so what I'm going to do is I'm going to write before and after. And let's see if we can work this out. So before, we can quite easily work out how many stickers Harry and Gary have, right? So before they have 300. And the ratio of H to G is 7:3. So Harry is going to have 7/10 times 300. Okay, and that would be 210 stickers. The way I got that is I divided by 10, so I get 30. 3 times 7 is 21, so add on the 0. Which means Gary gets 90 stickers. Okay. So if you notice here, there are 10 parts. Now afterwards, the number of stickers is still the same, it's 300, right? But the ratio is now 8:7. Okay, well, I should write it out fully, my bad. Is now 8:7. So the total number of parts is now 15 parts. Now there's a few different ways that you can do this. Okay, if we want to work out, if we want to work out exactly how many stickers they have, one way which I'm quite partial to is if we have 15 parts, right? What if I make this ratio equal to 300 parts? So how can I go from 15 to 30? To 300, sorry. I can times the whole thing by 20 to get 300 parts. So I'm breaking up 300 stickers into 300 parts. That will give me the exact number each of them have. So all I need to do here is times both sides by 20. So that would be, times by 10 is 80, times by 2 is 160 to 140. So in other words, Harry has 160 stickers and Gary has 140 stickers. I'm going to stop for a second just to check if you guys are okay with that. So Lila, are you okay? Evie, are you okay? And anyone else that's watching? Yeah, okay. Got it all, perfect. So now we need to say is how many stickers Harry gave to Gary. Well, two ways to work it out. Work out the difference between 210 and 160, or the difference between 90 and 140. It's the same. It will be 50 stickers, right? Because Harry has gone from 210 to 160, so negative 50. Gary's gone up 50, so he must have given him 50 stickers. That would be the way I do it. In terms of if there's another way, mainly the same way, but I hope that that's okay. But I like to break it up into 2 bits, split my page down the middle, do all that stuff. Okay, other than that, let's have a look-see. I can't quite remember this question. Let me read through it again. Twice as many blue as yellow. Okay, this one might be easy, to be honest. But let's go through it because what I find is a lot of students tend to mess up on just the worded questions, right? So if they give you the ratio, it's all good. But when they explain the ratio, it's harder. So I'm going to just go through it just for my peace of mind. So, again, take it piece by piece. Let's look at this piece of information. There are twice as many blue as yellow. So blue to yellow is 2 to 1. Are you all okay with that being the ratio? I explained it a bit earlier, but I don't know. I didn't really ask if you guys got it. Is that okay? Splendid. And then there are 3 times as many red as yellow. So red to yellow is 3 to 1. So the ratio of blue to red to yellow is just going to be, well, since the numbers are already the same, right? We can say blue to yellow to red is just 2 to 1 to 3. Because again, the number of parts is the same. So it's all good. So if you wanted to write blue to red to yellow, all you have to do is swap these around. For blue to red. Oh. Okay. If you're fine with that, then this is the same question. So let's leave that. Points, again, it's going to be the same thing. Two people in school canteen, half of the people are year 11. Okay, this might be a bit tricky. Maybe? I'm hoping something's going to catch you guys out at some point. And we'll go through in just a second. Sorry, I'm just checking something. Okay, cool. Sorry about that. But yeah, let's go through this then. So 120 people in a school canteen. Okay, half of the people are in year 11. The number of year 11 students is 3 times the number of year 10 students. The rest of the people are year 9. So work out the ratio of, basically work out the ratio of year 9 to year 10. Okay, so we have 120 people. Half of them are year 11. So if I write Y11, that is 60. And then we have year 10 and year 9. Okay? And we have, sorry, the number of year 11 students is 3 times the number of year 10 students. Oh, did I misread that completely? Oh, no, I didn't. Okay. So, basically, it'll probably be in about 20 minutes, 20-ish minutes. So, year 10 is going to be a third of year 11, so 20. Is that okay? So is that okay so far? So because there are 3 times as many, yeah, perfect, cool. The rest are year 9. So in total we have 80, and there's 120, so year 9 is going to be 40. So year 9 to year 10, if we're doing year 9 to year 10, we start off with just 40 to 20. Divide both by 20, we get 2 to 1. Not bad. So n is equal to 2. It's only a 2-mark question. But yeah. Okay. That's wrong. Okay, that should be fine. That should be fine. Okay, I think I underestimated you guys. I think you're finding a lot of this easy. So what we can do is go straight to the last questions. Actually, wait. I think that's fine. So this is like the two... Wait, did I miss one? No. So this is like the double ratio thing. Would you like to go through this one? Or is it still too easy? If not, I can just jump straight to the end. I haven't actually worked it out, to be honest, Evie. Let's work it out and see if you're right. So adults to children is 7 to 3. Easy. Okay. So yeah, children would equal 10% of the... Well, sorry, 3/10 of the population. Population? Sure. And then you times it by 2/5. 6/50 times 100. Not 15%. Not quite 15%. Did you make a mistake or did I? Oh, okay. So that's 6/50 times 100, so that would equal 12%. Ah, okay. Yeah. Also, it's a good thing that you guys are willing to point out my mistakes. But yeah, 12%, good. Nice. Okay. Honestly, this is a very similar question to what we just did. Instead, we're leaving it as a fraction, though. But let's go through it, because it wasn't too bad. Men to women is 2 to 3, and 30% of the women are under the age of 30. So women make up 3/5 of the company, and 30% is just equal to 3/10. So all you're doing is doing 3/5 times 3/10, which is 9/50. And that'll be our answer. Does that all make sense, is what I was trying to say? Okay. I'm sure you guys asked for help on this. Okay. Hang on. Wait. Okay. Something bad's happened. I did have other ratio questions, but they haven't saved. Give me 2 seconds. I'm just going to put these on now. I promise you there is harder ones. I've got them saved, so it shouldn't take too long. But yeah, I apologise for that. Okay. Pages 7 and 8. Yes, sorry about this. It seems to not have saved when I did it. Okay, and what are we looking for? Oh. And okay, it's a bit disjointed. Wait, hang on a minute. Okay, I apologise about that. That was not ideal. Okay. So Lila, is this the kind of thing you're talking about? So the questions I've just got now are Maths Genie. Yeah, Evie. Yeah. But for some of the questions, I do go through past papers as well, and I get the questions from there. So some of them are past paper questions as well. Okay. So it seems like at least these. Okay, it seems like these ones are going to be difficult. At least a bit tricky. Maybe, possibly, slightly. It is quite frustrating that they didn't save, but. Well, bear with me a second. Okay. So. This might be a bit more tricky, I'm hoping, ever so slightly. So, let's have a look at this. Okay, this is where things get slightly more tricky. So, ratio of A to B is 5 to 1. And then I'm going to put C to D over here, 2 to 3. Okay? Now it tells me that A plus B is twice C plus D. So A plus B is 6, C plus D at the moment is 5. Okay? Now what I want to do is I want to combine these ratios together. So I need to work out the lowest common multiple of 6 and 5. Okay? Does that make sense so far? Okay. So the lowest common multiple of 6 and 5 is 30. So to do that, I times this one all by 5. I times this one all by 6. So my A to B now is going to be 25 to 5. Bear with you 2 seconds later. I'll explain it in 1 second. So the reason for that is what we're going to do is we know that 2 times the number of parts here. Yes, that's exactly right. That's exactly right. So we take the lowest common multiple so we can split them properly, because we need to be able to divide all of the parts into it. So yeah, it's so we can get 2 times. Okay. So we know that C plus D is 2 times smaller than A plus B. So now I'm going to divide it by 2. And that will give me 6 to 9. Is that okay so far? And because we've split up 30 parts evenly between A, B, C and D, we now have our final answer for A to B to C to D. It's just going to be, so A to B to C to D. It's going to be 25 to 5 to 6 to 9. So the reason why this one's tricky is normally when we combine ratios, right, we have a common letter. But this time we don't have a common letter. So, absolutely, yeah. I'm going to scroll out slightly as well. So let me run it through one more time. Actually, I'll give you a second to read it and then I'll run it through one more time. Yes. So normally, right, when I want to combine a ratio, I have to have common letters, right? Like it might be something like A to B, and then I have B to C. I can combine that if I make the B's the same, right? But if we have no letters in common, I have to split them into their lowest common multiple. Okay, so good question. Why do I add and why do I times by the opposite? So we add because in this part here, where it has these 2 bits, they're talking about the number of parts each side has. So A and B together will have 5 plus 1, which is 6 parts. And C and D will have 2 plus 3, 5 parts. The reason why I then times by the opposite is I wanted to find the lowest common multiple. Now, technically speaking, you don't need the lowest common multiple, right? You just need a common multiple. Because at the end, you can simplify, right? I can't simplify. I've already got the most simplified version of the ratio. If I, for example, went up to 60, I would be able to divide my ratio by 2 again afterwards. So the reason why I said lowest common multiple is because it's the one that you won't have to simplify afterwards. But you will have to simplify if you pick another common multiple. Does that answer your question? So the only way to combine letters that are completely different is to first get a common multiple, ideally the lowest common multiple, and then split them like that. I'll give you a second just to chew on it. But once you're okay, just say yeah. Evie, do you have a bearing question with you, or do you want me to just pull one up? Oh, because your test is tomorrow, isn't it? You have one? Okay. Absolutely. But just make sure it's not one of the scale ones, is it? Like, do you have to use a protractor and a ruler? Because if so, that's a bit tricky for me to do. On the computer. Anyways. Okay, cool. Okay. And Lila, are you okay with that? Okay, good. Because guess what? The next question is... Actually, no, forget that one. The next question is basically the same. I want to do the same question again first, if that makes sense. Right? The same style of question. So we're going to do the exact same thing. Okay? So let's write out the ratios. We have A to B is 4 to 3. Then you have C to D, which is 1 to 5. Okay. So, number of parts, we have 7 parts here. And we have 6 parts here. Okay. So, we need to, again, times them by each other to find, in this case, the lowest common multiple. So if we times through by 6 here, times through by 7, we will get 7 to 35 will give me 7 times 6 is 42 parts. I don't know why that slipped my mind for a second. And again, that would be 42 parts. Yes, it does, Lila. Yeah. So if in the previous question I went up to 60, right at the end, I can divide the whole thing by 2 because 60 is twice as much as 30. So if you don't do the LCM, it's fine. Okay, completely fine. It's just this. It's not really the easiest way, but the simplest way is to find the lowest common multiple. But if it's easier just to find one that's higher, that's totally fine. You will get full marks. And this would be 6 times 4 is 24. 6 times 3 is 18. Okay. Now, if we have a look at this part of the equation here, it tells me that A plus B is 3 times C plus D. So I need to now divide this one by 3 because it's 3 times smaller. So that'd be 8 to 6. And then all I need to do is join them all together as we've done before. So A to B to C D will be 8 to 6 to 7 to 35. I would say this is probably the hardest style of ratio question you can find. Or at least it's one of the ones that are really out there. But is that all okay? Yeah? Okay. So I think the ratios are okay then. Next week we'll do vectors, followed by bearings. So I'm just going to write another note to myself in case I forget. Vectors, then bearings. And we'll decide on the topics after that as well. Eventually we will just start doing like exam papers and things like that. Okay. If that's all okay, then what we can do is go on to the stuff that Evie mentioned. So there's a bearings question that Evie wants to send. And then I'll also talk through the A-level physics stuff briefly for that as well. So So the reason why I can't just stop doing the GCSE live is because I've already started it. So it isn't fair to the other people that need to do it. I will find a day for A-level physics as soon as my schedule opens up. Okay? But I can't just kind of stop doing the GCSE stuff. In terms of A-level physics, the breakdown is you basically get even marks for each of the 3 papers. So can I ask what exam board you're doing for A-level physics? And Evie, if you send your question, that'd be good. Okay, so the way that will work is you have paper 1 and paper 2, which are both 80 marks, I want to say, but it could be 60. And then your paper 3 is split. So half of paper 3 is going to be your chosen topic. So you're going to choose between like astrophysics, turning points, engineering physics, electronics, and what's the last one? Medical physics. So that's how it breaks down in that case. And yeah, Evie, as soon as you send that question, I'll... or if you send me where to find it, I can do that as well. So AS tends to be paper 1, A2 is paper 2. Where did you send it, Evie? Did you email it to me? Yeah, so generally speaking, the AS content is in paper 1. I don't see it. I don't think you can attach pictures if that's what you're trying to do. If you want, you can email it. I'm just going to type in my email. And then I'll put it on the screen. So yeah, paper 1 tends to be the AS stuff, and paper 2 is the A2 content. So things like capacitors, gravitational fields, further mechanics is in A2. Oh, hello. Okay. Okay, that's sent. The first part did. So crow flies 23 kilometers at a bearing of 43 degrees, then flies 47 kilometers. Okay, so we'll start. Yes. Okay. Evie, I like this. Okay. So, let's say the crow starts here. Now, bearings are always clockwise from north, as you may know. So if it's on a bearing of 43 degrees, that should be something like that. So the bird flies about, let's say that much. And that's 23 kilometers. And it stops. Then it flies due south. So due south will be directly down. And it ends up here. And that's 47 kilometers. I think that's everything. Okay. And then you have... Okay, that's a terrible triangle. Wait, do you get it already? Oh, I see. And hopefully you can see that this angle here is 43 degrees as well, right? Because it's a alternate angle. These two sides, these two things here are parallel. Yep. Yeah. So how far south of its starting point? Okay. So what you would do here is I would split this into a right angled triangle. Okay. Yeah, this would be the best way to do it. So that 47 kilometers is a bit deceptive, you know. So if I just change this quickly. Oh god, of course it. Something like that. What we're trying to work out is this length here. Okay? And we have the total length. So the way I would do it is I've split it in half so it's a right angle. We're looking for the adjacent side. This is the opposite and that's the hypotenuse. So we have adjacent, we have the hypotenuse, so we're looking for, if we're doing SOHCAHTOA, which we are, we're looking for this one. So we have cos 43 degrees is equal to adjacent, which is the side I care about, over 23. So adjacent is equal to 23 cos 43. Stop me the second this doesn't make sense, by the way. I need to use a calculator for this because I can't do cos 43 in my head. So 23 cos 43, 16.82 blah blah blah. So, now that isn't my answer. The question says, how far south did he land? So that's going to be this length here, which is just going to be 47 minus 16.82. So if I just do 47 minus answer, 30.2 kilometers, let's call it. So, Evie, is that okay for you? And Lila as well? So, sine 47 times... Oh, I see what you did. Yeah, that should give you the same answer. Wait. Yes. So, 23 sine 47 gives you the exact same answer, yeah. You can. That's perfectly legitimate. Well done. So what Evie did is she noticed that this angle here would be 47 because 180 minus 90 minus 43 is 47. And so she can use sine instead. Completely fine. So with trigonometry, the good thing is it doesn't matter which angle you use as long as they're right, and which trig function you use as long as they're right. So really well done, yeah. So if you wanted to, you could have used sine 47 equals opposite over 23, and it gives you the exact same answer of 16.82. Yeah. So with bearings, always draw it out. Always. Okay, paper 3. Paper 3. So, sorry. Okay, so I'm being careful with what I say, Lila. Histograms only come up in paper 3, and they're likely to come up in paper 3. Okay, so they come up a lot of the time, but not all the time. So things like, what I will say will, if I had to bet my life on it, okay, with paper 3, if you had a gun to my head, I would say probability. But it would be things like relative frequency, right? So in the sense where it might be like, oh, we toss a coin 300 times, I get 127 heads and whatever tails. What's the probability of relative frequency? I would say grouped frequency tables. It's very likely to come up. It guaranteed. So they may ask you to find the median / the mean. This mode. That also includes histograms, right? So they can ask you to draw histograms from that. But group frequency table is guaranteed. Probability guaranteed. Let's think, what else might they add? Oh, error intervals. It's very statistics-y. But other than that, they'll likely ask you to draw like frequency polygons or scatter graphs. It's way more stats, yeah. So stats basically only appears in paper 3, which is why most of it will be stats, right? Because they need to make sure that you can do it. So again, with probability, usually it's relative frequency, but they can also ask you for things like the tree diagrams. Ah, that's tragic, Lila. I had COVID as well myself. But I'm not in school, so I didn't miss anything, obviously. But yeah. It's... Honestly, histograms are surprisingly tricky. Scale factors, yes. Shape transformations, less so. It can appear, but not as common, okay? But scale factors is a pretty good bet. But yeah, I completely agree. Missing stuff because of COVID sucks. Histograms can be actually surprisingly tricky. So like with the estimations they make you do, can be a bit tricky. Box plots. So the reason why they love box plots is they have things like interquartile range. Not really, Evie, to be honest. Not really. That's more paper 2. Actually, paper 1, really. I'm not saying it won't come up, but it's not very likely. Paper 1 is more equation of circle stuff. But box plots like interquartile range and comparisons as well. If I can learn how to spell, that would be perfect. But yeah, equation of circle, not really. Honestly, there's not much with equation of circle, right? You just need to know that it equals the radius squared. There's not that much to do with it, because the centre has to always be the origin for GCSE. For A level, it's slightly more difficult, but it's not too bad. It's not easy, but it's not the end of the world. So I think that's all we have time for. Wait, they're not giving you the formula sheet, really? That sucks. That's really bad. The only thing I will say is if no one has the formula sheet, you're all going to have that disadvantage, which means your teachers may change the grade boundaries. If they don't change the grade boundaries, then that's just not fair. It's just plain not fair. There's no reason for them not to give you the formula sheet if they're... Yeah. Because if they're using if they're using the grade boundaries from the year that they're taking the mock, then they have to give you the formula sheet, otherwise it's not fair. If they've made their own paper and they're doing their own grade boundaries, then they'll just change the grade boundaries. But yeah, that's unfortunate. It's not that bad. Really? Okay, then that sucks. That sucks. Although 2022 papers had stuff taken out of them, by the way. Like, not all topics were tested. So if you look up the advanced information, there's certain things that weren't tested in 2022. So it might be a good thing. They were easy because of COVID. So they gave people a bit of a break. Were a bit lenient. Although it means the grade boundaries are very high. So that's the problem, is if you have an easy paper, grade boundaries are really high, which means your mistakes cost you more. Whereas with a harder paper, mistakes cost you slightly less. Because it's just a hard paper, there's low grade boundaries. Okay, I'm not sure if you have a mock exam coming up, Lila, but I know Evie does, so I'm going to wish you the best of luck for that one tomorrow. Do remind me how it goes next week. And again, Lila, I don't know if you have mocks, I can't quite remember, but best of luck if you do. This week? Okay, then best of luck with you as well. You're very welcome. Thank you for being so interactive. It makes it more enjoyable anyway. But yeah, I do appreciate it. You're very welcome. But have a good evening. Best of luck with your exams. And I'll see you next week.